Okay, so how do we measure income inequality? So there are like a couple of ingredients that we need, and one is the Lorenz curve. So the Lorenz curve plots the relation between the cumulative fraction of the population and the cumulative fraction of total income earned with people ordered from lowest income to highest income. So we can think of it that we take our population and we tell the population, look, line up from lowest to highest income. And then we take the first 20% of the population and we look how much of the total income do they get. And then we go to the 40% and we ask how much income do the 40% poorest get. And then we go to the 60% and we ask how much of total income do the 60% poorest get. And then we do the same for the 80% poorest. And of course we do it for the 100%, but of course 100% of all the people, they get 100% of income. So the Lorenz curve goes from 0 to 100. Okay, so the Gini coefficient is now calculated as the area between a so-called equal income distribution line and the Lorenz curve over 5,000. So it's probably not clear why that is, so we need to work through an example. Okay, so here we have the cumulative population quintiles. And we have here country A that actually has a perfect equal income distribution, because the 20% poorest, they hold 20% of total income, the 40% poorest 40%, the 60% poorest 60%, the 80% poorest 80%, and of course 100% hold 100. Okay, so now let's draw the equal income distribution line, and maybe I'll do that in blue. And then, okay, 20% get 20, so I'll make a dot here. Then 40% get 40%, I'll make a dot here. 60% get 60%, I'll make a dot here. 80% get 80, and 100. Okay, so maybe I'll just connect those dots. So now this is our equal income distribution line, and we compare that with the actual income distribution, which I do now in another color, maybe orange or so. Okay, so now we go to country B. So the 20% poorest, well, they are really poor because they have only 5% of total income. So that is roughly here, cumulatively. And 40%, they hold cumulatively only 15%. So that would be roughly here. 60%, the 60% poorest hold only 30% of total income. So that would be here. And 80% of the entire population have only 50% of total income. And that means that the remaining 50%, well, they have the remaining 20%, they must have also 50%. Okay. So this is, when we connect those dots, we get the Lorenz curve. So let me try to draw that maybe nicely. So the first line goes from here to here, then here, here, here. Oops. Okay, perfect. So this orange line is the Lorenz curve. Okay, so now what we need to do is we need to calculate the area between the equal distribution line, the blue line, and the orange line. So what we want to we want to calculate this area. Right? So how do we calculate this area? So the orange area, we can calculate them the most conveniently if we do first, we take a look at the area underneath the blue line. So we take first the area underneath the blue triangle. And this area underneath the blue line, well, that is 5,000. Why? Well, it's a triangle, 100 times 100, that's 10,000, over 2, that's 5,000. And from this area, we now subtract, so minus the area underneath the Lorentz curve. So this is, let's say, the Lorentz curve. And what we do is we calculate the area underneath it. So this is actually, what I will do is, what we calculate is the area underneath it. And then if we subtract this, what we get is the area between the underneath the perfect equality line and above the actual Lorentz curve. So then we get the inside here. So we do 5,000 minus the area underneath the orange line, and that will give us the remaining area in between the blue and the orange line. So, okay, so what we do is we calculate the area underneath the orange line. Okay, so let's start. Okay, so this area here is a little triangle. Let's call that A. And A is equal to 20 times 5. That's 100. Because here, this is cumulative 5, right? A 5. So we do 20 times 5, that's 100, but it's a triangle, so we divide by 2. So area A is 50. So next we have a rectangle. Okay, call that B. And B is 20 times 5, so that's 100. But on top of the area B, we have another triangle. Let's call that C. And that is the distance between 5 and 15. So this here is 10, and this distance was 5. So we have 15, we have 10, the height of the triangle, 10 times 20, that's 200, over 2, so that's another 100. Okay, so now we have again a rectangle that begins at 15. Okay, so this I call that D, this area is D, and that is 20 times 15, so that's 300. And then on top of it we have again a triangle. And that triangle goes from 15 to 15, so that height is 15 times 20, that's 15 times 20, that's 300, over 2, so that's 150. Okay, so then we have again a rectangle. I call that F. So F is 20 times 30, that's 600. And then on top of that one we have another triangle. I call that G, and that goes from 30 to 50, so the triangle's height is 20. 20 times 20, that's 400 over 2, so that's 200. Okay, so now the last area is another rectangle. I call that H. That's 20 times 50, that's 1,000. I put it here, H equals 1,000. And then on top of it we have again a triangle, which is 50 times 20, which is 1,000 over 2, and let's call that area I, so that is 500. Okay, so now let's sum up all this area. So now we have 50, 150, 250, 550, 600, 700, 700, 1,300, 1,500, 2,500, 3,000. So the total area underneath, so this area here, is 3,000. Okay, so this area is 3,000. So the area between underneath the blue line, since that is 5,000, and I subtract that everything that's below the orange line, that is 3,000. So the area between the equal opportunity line and the and above the Lorentz curve, so this area here, so this area is 2,000, because 5,000 minus 3,000, so that is 2,000. Okay, so now the Gini coefficient is So the Gini coefficient is 2,000 over 5,000, which is 0.4. And okay, so if we had, for example, a situation which is characterized by perfect income inequality, so let me erase this one here. So now we consider a case which is characterized by perfect income inequality, then we would have to think that 99.999% they have nothing, and then 1% has everything. So now the Lorentz curve would look like this orange triangle. And now you would see that the area between that equal distribution line and the Lorentz curve are the same. So the area here, now we would get a Gini coefficient where we would take the area below the blue line, that's 5,000, and we divide by the area above the, we take the area between the equal opportunity, the equal income line, and the area between that new Lorentz curve, which is 5,000, and divided by 5,000. So now here this would be a Gini coefficient of 1, which means perfect income inequality. And of course, if there is no difference between the equal opportunity line and if there's no area between the equal opportunity line and the Lorentz curve, So if the Lorenz curve also looks like this, well then, okay, it doesn't know. Okay, so it doesn't. So if there's no area in between, well then the Gini coefficient is 0, and that would mean perfect equality. Okay, so now we can summarize that again here. So that's just what we just did. So we always had the rectangle and the triangle, and between 0 and 20 there was no rectangle, so that area was 0, and then we had here 50, and now we have to always switch back. Then we had 50, and then we had 100 and 100. So here we had 100, 100. Then we had the rectangle of 300 and 150. So that 300 and 150. And then we had 600 and 200. And the last one was 1,000 for the rectangle and 500 for the triangle. Okay, so now we have here 50, 150, 450, 800 and 1,500. And then we said the total sum is, so we calculated the area again underneath the orange line. So the area is now 50, 200, and then 200, 650, and then 650, and then 1400. Oh, by the way, there's a 100 and 100 obviously is 200. So 200, so 250, 500, 700, 1500, so 3,000 again. So the sum of all the areas, I just call that sum areas, that is 3,000, and that's the area underneath the Lorenz curve. So the area in between is 2,000. And because country A has no difference to the equal distribution line, the Gini coefficient for country A was 0, because basically what we do is 0 divided by 5,000, it's still 0. But for country B, we have to take the area in between 2,000 and divide by 5,000, and that's 0.4. Okay, so this is how we can calculate the Gini coefficient. And so I don't want the video to get too long, but in the next video I will show you how we can turn this one into a very nice Excel application. But I'll do that in the next video, and I hope to see you there.